Contract 2 of the I&I project, $329,309.78. Rural Development.
Make a motion to pay.
Second.
All in favor?
Next is Bocook Engineering for the engineering on the I&I project, invoice 9, $30,056.13. Also
Motion.
Rural Development.
Motion to pay.
Second.
All in favor? Motion carries.
Next, Boca Enterprises, invoice 1 on the Route 40 West replacement line relocation, $21,280, funded by Kentucky Transportation Cabinet.
Second.
All in favor?
Aye.
Motion carries.
And we also have one requested change order on contract 2 of the I&I project for Thomas Environmental. It's change order 3. And it's for required changes to the railroad crossing, $59,520. And there's a copy of that change order in your packet.
So I have a question about that
Sure.
change order. How do you bid something and have that kind of massive change order?
But there's two elements to that. One, the decision was made to go with a larger line size to get better flow. And then the railroad required thicker encasement.
Thicker encasement than.
It was designed, yes. And we kind of have to go with what they say.
So, and I understand, I just
Yeah.
hope to get a better understanding of this. For the additions on the bottom one, it says 30-inch bore and jack. And then we turn around and do a 30-inch cut for the exact same space. What do we well, I mean, it's 60 more feet. So what is the difference between a bore and a jack and an open cut?
Bore and jack is where you have to actually bore underneath without disturbing existing ground on top, which would be the railroad tracks. Open cut means it's just laying in a section. You just go out there, excavate down, put it in, cover up.
So we're adding, if I understand this right, a 30-inch open cut, 60 feet more.
Well, no, like Bob said.
It's replacing the 24-inch.
You was supposed to do a 24 without, I guess, something didn't happen, got checking with the railroad. Railroad said, no, we have to have something larger, and they want at least a 30-inch used. So we're deleting the 24 and making it a 30 instead, because both lengths are the same, the 100 feet and the 60 feet.
So the difference is we're going from 63,000 to 122,000.
No. Well, you subtract those two, and that's at 59,000.
Yeah.
Yeah, that's the difference.
Due to the railroad requiring it.
Rural Development's paying for this?
It's our funding package, yes.
So is it fair to say that someone made a mistake in the original design or didn't take into account that the railroad was going to require this or that? Or, I mean, I don't know that it's a big deal because it's going to be done, but, you know.
I know the railroad came back and said, this is what we want.
Well, like it said, nobody checked with the railroad what they're going to forward the bid. So we're going to change it back. I don't know whose responsibility that was,
Well, remind us what the total budget for this project is here, the contract to.
Yeah, then we-
About 3,227.
It's in the 2.7 range.
So it's
Yeah,
not
million.
just a huge percentage of the total deal.
I make a motion that we approve the change order to Thomas Environmental for $59,520 for the changing of the 24-inch bore and open cut to the 30-inch bore and open cut.
For a second?
Second.
All in favor?
Aye.
All opposed? Motion carries. Okay, so we've got, looks like legal service invoices.
I'll make the motion we pay legal services.
Second.
All in favor?
Somebody-
All opposed? Carries. Other operating invoices? particular?
It's mostly your normal expenditures. We do have the annual charge from the Corps of Engineers for right to withdraw water. That's $46,000 and change, based on their budget.
Make a motion that we approve the other operating invoices for payment.
Second.
All in favor? Opposed? Motion carries. Departmental reports.
Any questions on what we've got there, or anything anybody needs to add?
We still repairing membranes, I see.
Yep.
So all the new ones we put in the 2 trains, all still doing well?
Yes.
They're gonna be a never ending,
We got them replaced.
huh?
Until we replace it with 2 trains.
Got we've replaced half of them, they're working fine.
You need an assistant membrane repairman.
Yeah.
We have the foremost membrane repair people in the country, probably.
Yeah.
Yeah. If you get our money back, we could rent these guys out.
Nobody else uses that system.
Actually, there's some.
Any other questions, operating reports? Does that require a motion?
Mhm.
No. Okay. So we move on to all business. All right. The I&I project.
Ready to report there?
Contract one's about mid-30% complete. To date, we've got, or till last week actually, we've got about 14,320 feet of line that's been lined so far. From the last board meeting, we've got a little over 4,000 feet lined the previous month. We did the repair of the creek crossing behind the library, which put 2 sections in and put 2 bands on, which hopefully will significantly help us.
Well, why was that so badly degraded, do you think?
It's just been since the 62.
Well, okay, so it's been 50 odd years.
That's the newer sections.
It completed a couple point repairs, installed 3 manholes, new manholes, replaced a couple of them. They've extended and raised the casings, changed the casings out and raised some manholes that they found that were buried. I think one of them, I can't remember if it's this month or last month, but one of them was 42 inches deep, buried about 42 inches. We're continuing to investigate the area over around Richmond Village, the Triple Crown subdivision. We found 2 manholes there that have been covered up, and right at 460 or Route 40, that manhole has water effluent coming through it that is probably groundwater, or not sewage, and it's actually got a leakage under the pipe too where it wasn't sealed, so we'll be addressing that. They found some leaks up in North Gate and found a leak up in Triple Crown also. Like I said, well, I think North Gate and Richmond Village, if we can find some interconnections, will make a pretty significant impact on the flow to the plant. I think we have made a significant amount. We're trying to go back now and maybe get some old records, compare with rainfall rates, comparable rainfall rates with flows and effluent coming out of the plant now. So contract 2 is about 35% complete also. The only work completed on that project is on the depot lift station where they poured piers for the pump base and installed the pump base, and they reinstalled them, and then they're starting to put the guide rails and brackets in. So they'll continue doing that. So their contract should, or their timeline shouldn't be any problem completing. I think he plans to get that finished by late fall at the latest. So, any questions?
When's contract 1 supposed to be done?
Oh, next spring.
Yeah. Everything's supposed to be done by April.
And it's going to be put a push on to get it done.
Okay.
I think too that on that, start thinking about it, on contract 2 for that boring on the railroad, they changed to also, which required a bigger casing, and because the PE pipe sticker, that's the reason they had to go to bigger casing, which is what and thicker casing, which is what the railroad, what they had before would have worked, but then it was an upgrade.
Thanks, Dewey. Ongoing projects.
The only thing I've got there is we still have some touch-up work to do on those sewer line replacements we did last year. Expected to meet with the contractor last week. Have to track him down again, see if we can go over and get those things done. We've got some people we need to take care of. Finish what left very good.
All right, moving on to new business, the wastewater treatment plant flow measurements.
Yes, we had questions about the accuracy of our flow measurements with the Paintsville sewer plant. We asked Bell Engineering to come take a look. James Roberts came up a little over a month ago and evaluated our plant, came up with a report, has some recommendations. I've asked him to come and discuss those with us.
Thank you.
Thanks for coming, Mr. Roberts.
Oh, you're welcome, anytime. I don't know, all of you know me, I've introduced myself to most of you, James Roberts.
Yeah, nice to meet you.
I'm the Executive Vice President of Bell Engineering. I've been with Bell for 40 years. I started working in Paintsville in 1978 when I started with Bell as a surveyor, coming down here to do work. So I've been around for a while, familiar with your system. But they asked me to come down and take a look at your influent and effluent metering at the plant. And so I prepared a report. I think, were you given a copy of this report previously, I think?
Yeah, I've got a couple extra copies here.
And I've got another one. If somebody wants to look at the bound one again, but I can, if you've already read through the detail, I can skip a lot and answer questions, or if you want, I can give you an overview of what I found.
It should be toward the back of your packets.
Essentially, the influent meter is located in a channel between the grits, or the screening channel and the grit, piston grit units. That channel's too short, it's too narrow, it's not deep enough. The meter is the ultrasonic head that measures the depth is not a correct application. And the weir itself has a flow range and an accuracy of measurement that is not low enough to measure your lowest flows and not high enough to accurately measure your higher flows. So there is a range that it will work, but it's a very narrow range. It's about 0.2 MGD to around 1 MGD, and I don't think all of your flows fall in that range. So, there are problems.
Was this a design flaw?
Not necessarily. When it was put in, that one was installed, I believe, 2014. It could have been some parameters that changed. It was probably the best location at the time for the least amount of money. If I were, I mean, I wasn't there. I don't know what the decisions were in putting that one in. But in looking at the the influent structures and the places to locate a meter, that would be the first place I would look as an engineer. Is I want to put it in a channel, but the channel's just not configured well enough to be able to measure what you want to measure there, at least not over the ranges that you experience at your plant. So there are, anyway, I looked at that meter. I went downstream, looked at the effluent meter, which is not strictly an effluent meter. You have the screening, the grit chamber. You go to 2 oxidation ditches. It comes out of the oxidation ditches and goes through what used to be aeration steps for an effluent from the plant. So that was an original effluent location, and there was metering at that location on the original plant. Later, in the 2000-2004 era, you came back and you added finishing clarifiers downstream, as well as chlorine contact. So now you've got an effluent meter that's sort of in the middle of the plant flow, not really on the effluent of the plant flow. So that's sort of an overview issue or a location issue. As far as the placement of that meter itself, the structure is large, it's longer, it's a wider channel. The primary metering device in the influent is called a rectangular weir. It's just a broad, flat piece of metal that sits across the channel and the water flows across it. The one for effluent is called a V-notch weir. It is a 90-degree V cut into metal and the water flows through it. They serve the same functions. They're good for different reasons. The V-notch weir is very accurate at low flows. So what I found was that the one that you have is good down to like 0.02 MGD. So that's, really dry weather flow, you ought to be able to measure accurately. But the configuration also would only allow you to measure up to about 1.7 MGD accurately. And you have flows that I know exceed 2.6 because that's the maximum on your chart, and you go off your chart. So again, there are less issues with the effluent meter than there are the influent. But still the range that it can accurately measure over doesn't match what your plant sees. I looked at both meters on was it possible to improve the configuration at the existing location in order to achieve better metering at those locations. On the influent, there's really not a possibility to change it enough to make it an accurate meter at that location. There's a possibility of putting in what's called a stilling well. You would core a hole into the side of that channel, bring a pipe over, put in like a manhole that would allow the water level to rise and fluctuate inside that structure, the same as in the channel. That might be, it would solve some of the issues that are with that location, probably about 30% of them. What it wouldn't solve is the fact that the weir itself is not suited for the range of flows that you receive. There's really not a lot you could do without major structural changes in that channel to make that influent meter work where it's located. The effluent meter, there are less issues to deal with. The biggest one is probably the fact that the effluent side of that weir becomes submerged frequently. So there's not free flow over the weir during all flow regimes at the plant. When you get into high flows, you can't get water out of that structure fast enough through the clarifiers and out the back of the plant so that you've got free flow coming over that weir. And in order to have accurate flow over a weir, you need free flow. It can't back up on the downstream side because that affects the water level upstream of the weir, backs water up. So one of the things that might be possible is to look at changing piping between that structure and the clarifiers, maybe some larger piping. We didn't go into detail looking at those design changes, but if you put in larger pipes, maybe you could move that water a little quicker to the clarifiers and keep from submerging the discharge. But still, the peak flow from that V-notch weir is about 1.72 MGD peak for accurate measurement. So again, you're limited. If you're not worried about significant accuracy above that level, I mean that should be an infrequent occurrence, then maybe it's something you could tolerate. But You're not going to get full range accurate flow with that meter location either.
Why couldn't you just do a V-notch in a different location?
Well, that's what's proposed in here for the effluent, is to move the existing metering equipment, the ultrasonic head and the controller, move those to the chlorine contact basin, which has currently rectangular weirs on it. They're not being used for anything except to control level discharge out of the chlorine contact. You could replace those rectangular weirs with 60-degree V-notch weirs and move the metering equipment to the chlorine contact, which is your final treatment structure, and reuse those there. And I think the
I was talking about just using almost what you got, but just moving it to a different location,
moving,
either upstream or downstream. I don't know enough about it
sure,
to know the,
I have a plan that I can show you, but there's really not enough. You're going to need a structure. You're going to need a channel that you can locate it in. So there's not another channel between the existing structures to utilize. You would have to construct a new channel to put that existing equipment in. The least expensive alternative on the effluent would be moving that existing equipment, as you've said, to an existing basin, which is the chlorine contact basin, and changing the effluent weir type from a rectangular to a V-notch. And
What entails changing it to a V-notch, just a metal plate?
you would unbolt or remove the existing plate and put in a new metal plate that has a V in it instead of being a flat.
Just calculate
broad
what
weir.
size you have to have due to the flow you're trying to.
Right, I have. It would take a 60-degree V-notch weir that's 1.5 feet tall, and that would fit within the existing structure. It wouldn't require any concrete work. You wouldn't have to deepen the opening where that existing one is. It would cause the water level in the chlorine contact basin to be about 1/2 foot higher. It would depend on the quantity of flow going over it, but you'd see a slightly higher level of flow in the chlorine contact basin.
Would that give us an issue there at a future date, or making a higher flow than what was originally looked for?
No, there's about 1.5 feet of freeboard in that basin at peak flow right now. You'd be using up, at peak flow, you'd be using up somewhere less than 1/2 foot of that. You'd still have 1 foot of freeboard above it.
Do you know if we've ever went above that down there on that freeboard any, or did we ever have anything flow out of that area that didn't stay contained?
Have you ever overflowed the chlorine contact basin? You have dual basins there, so the flow is split between the two of them, the total flow. And there was a very nice free fall discharge out there that I don't think would ever back up unless the river got up over it, which is potential, I suppose, but
And we were at high flow when we were here.
yes.
so how much difference would that be from the 139,000?
Well, we're
To use the metal plate like you're saying and go back?
Well, we're talking about the effluent meter at the moment, and the cost to go to the chlorine contact was about $30,000. The other alternative on the effluent is to go to the effluent line that's going to the river. Between the chlorine contact basin and the river is a pipe, and we would recommend that you install a mag meter in a vault on that existing line. It's a more accurate meter, measures over a much wider range, and would give you more accurate information. The cost for that would be we're saying construction cost around $75,000. So that's the two alternatives on the effluent. Move the existing equipment, put in a V-notch for around $31,000 in construction cost, or to build a vault over the existing line, put a mag meter in it, and that's about 74, 75, the number we had in here.
So that one's kind of an either or.
Yes, sir. They both include connecting or reconnecting the existing SCADA system. There is, on the effluent meter at your plant, is connected to a meter in the head house or in the operating room that drives a chart recorder. They keep a chart every day of the flows, and then they also record a peak flow each day, I believe, manually. It displays, there's a digital display, and they'll read a peak flow to record daily, I believe. Is that correct, Blaine? On the effluent. On the influent, there is no indication in the control room of flow. They have to go out to the unit at the screening channel in order to read the meter to determine what the flow is on the influent. All of our proposals include connecting both of those devices to a SCADA system in the control room so that the operators could read it locally, monitor it locally, and then it would also archive and record the data digitally, and you could still have a chart recorder if you want to continue to produce a hard copy chart of both influent and effluent if you wanted. And that's included in the line items under electrical and SCADA work.
On the effluent between the two, what would your recommendation be?
To put the mag meter in, and not because it's more money, but because you'll get more for your money. Putting in a meter that will record over a broader range more accurately. It's not prone to freezing. If you get very cold weather in the winter, I'm sure you can see some freezing in the pouring contact. It's also not depending on an ultrasonic device, which is temperature sensitive. The device, which one of the notes I made in the report, the effluent device, ultrasonic device, has an external temperature sensor with it so that it can adjust. The influent does not have an external temperature sensor. But the mag meter is not temperature dependent. It's accurate over its full range. So that it would be my recommendation, or our recommendation, that we use a mag meter both on the influent and the effluent.
So do you think the meter on the influent was just not set properly?
It has been calibrated. It can be set in the original. I wasn't, again, the engineer on the installation of that meter, so I don't know what criteria they were given to establish the installation or choose the type of device. My belief would be that it was cost driven and it was the best available solution for the least amount of money at the time, trying to reuse or use an existing channel. The weir is located in a slot that was originally designed to have a stop plate put in it so that you could divert flow around the Pistogrit facility. So there was a stop plate or a stop gate went down in some slots in the concrete. They've taken that, reused that, and cut a weir plate and run it down in those slots to create the rectangular weir, which indicates to me that they were looking for a low-cost solution. And over a certain range, like 0.2 to 1 MGD, you can get reasonably accurate results. I don't think you're ever going to match influent and effluent results with the influent and effluent meter setup that you have. They had been calibrated within a month of my visiting the plant. They had tags on them that showed that, I think C.I. Thornburg had been down and calibrated both of the meters. And you can calibrate them where they are for a specific flow, but that doesn't mean they're going to be accurate over a wider range.
Let's say your system, as you do all this and all of a sudden your influent is way out of whack, what could you do in your system to make it work? Not the measurement, but to the system. I mean, what difference is this going to make if you're out of compliance anyway?
Well, it gives you...
Just because you can measure it don't mean that it's working.
Well, you can at least compare...
You feel guilty about not doing it right.
Yeah. Right now, you can look at the readings you're getting at the plant, and you can't reliably determine whether or not you're having really what the true impact of your I&I work is, because you don't have accurate flow measurement at the plant. You can record it all day, you can look at it all day, you can look at flows at rainfalls and not rainfalls, but you can't compare the two to say, well, we had a 2-inch rainfall following a 2-week dry period in March of last year, and this year we were lucky we had a 2-week dry period and a 2-inch rainfall again, so I ought to be able to compare those flow records and get some idea of whether or not we've made any progress. But you can't do that today. because the flow measurement devices that you have are not giving you accurate or precise results. And replacing them with, on the influent end and effluent would give you the ability to make those determinations. Are we just treading water, or are we actually gaining on it? And then having an accurate influent and effluent will help the operators understand better how the plant's operating and how to better control the processes there, which they can't compare influent and effluent today and be confident that they're looking at good numbers. They can't really, you can look at it and you can make a comparison, but you don't know that the results that you're getting reflect reality. Probably close.
And the indications we have is that we're over reporting our effluent. That's a big deal. These numbers are sent to the state every month, the daily flows. And we're reporting, we have significantly less influent than we have effluent. But that just doesn't look right.
You're boiling a lot of water at the plant somewhere.
We have
Boil it off in steam.
Say that again.
We have significantly more effluent than we have influent.
But the current effluent is actually not taken into full consideration of the whole system like you said then, so something else is going on in there too. Because if we've got less, if we've got more going out than what's coming in, and he already said the systems need to be put farther down the stream to catch what you're actually doing, so if we want to do even more.
The problem is your measurements are just inaccurate,
Yeah.
especially on the influent side.
So there must be something else in there.
And the current location of the effluent is also impacted by recirculation within the plant. If there's a plant drainage pump station that discharges back to the head of the plant, and it takes all of any wastewater inside the plant that's sent back to the head to go back through the system again is being measured through that effluent meter right now because it's in the middle of your flow path. Whatever's recycled within the plant is being measured when it's recycled.
So it gets moved farther down the system.
We're moving it beyond any recycle point at the chlorine contact or the line going out of the plant gets it beyond measuring the recycle.
Yeah. But should we be recycling that?
Yes, that's a normal part of the plant operation, is to take water within the plant, recycle it for a number of different reasons. It's a normal plant function. It's got to exist. It's just that where we have the meter currently, or where the meter's located currently, is including that recycling water.
Once it gets moved, you're talking about, you don't think it floods in the area where the meter would be put?
Does the river go up into the chlorine contact? I would suppose that at some major level that it could, but it's above.
Is that how above?
Yes, the facilities were designed above the 100-year floodplain. So as long as it's not more than 100-year flood.
Bob, where was the data taken that led to the I-9 project? That is,
At these meters.
which we now say are inaccurate. Well, no, this may be a dumb question, but I mean, is it possible that the I-9 project wasn't actually necessary? That in fact we just had bad data?
No, we're not that far off. Where it's going to impact is at high flow. And correct me if I mistake this, we are significantly overstating our effluent. It's based on averages. So that just pulls us further and further out. We would still have been out of compliance.
On any reasonably accurate measurement, we would have been out.
We would have been, yes.
Okay.
Your measurements are not so inaccurate that they're totally unreliable. They're just not a precise picture of what's occurring.
Well, not actually reportable, because by permit, we're supposed to have a precise measurement to send in every month, and we know they're not.
Yeah.
So that right there, I'll make a book that you have to find.
So how many years we've been doing that?
Ever since I've been here.
I think some of this stuff probably needs to be talked about in executive session before we say too much in open session. So if you got a criticism, that's something that probably needs to be addressed in executive.
Anything else I can answer for you, or?
Wasn't it kind of a no-brainer when we added the additional process that we put the effluent meter down below that to actually measure the work that we're doing? It's kind of odd to me that it's there in the middle of things.
I was at Bell. Bell did the clarifier project in 2000. I wasn't on the design team. I can go back and look and see. We installed the rectangular weirs in the chlorine contact, which would indicate to me that there was some effort or indication or thought of measuring flow at that point. You can measure it today. You could take a ruler down and measure the depth, and I can give you the equation on those. You can do it by hand. But why, the existing meter was located in the post-aeration flume at the time, and the new meter was left in the same place. Again, it could have been a cost-driven decision. I'd be glad to try to look it up for you if you'd like.
That's all right. Any other questions for Mr. Roberts?
So to do it the way you're recommending in terms of a cure would be right around $200,000. $139 and 72, in that range. 202 to 210, something in that range.
In terms of construction costs.
Is there more costs other than construction costs?
You have your engineering fees.
And then after it's done, we'll be able to calibrate and measure and see how accurate we are at that point.
Yes, sir.
Mhm. Any other questions? Appreciate your really meticulous report. Thank you.
Put that metric down there and make it.
You actually handle it by hand at a given moment, but it doesn't give you your 24-hour flow.
Probably everybody's volunteering.
Another 15 minutes at work.
Is that a new job?
All right. Go on to this AD, water improvement system, water system improvements.
Yeah, the plans for that phase 1 of the water system improvements are with the Division of Water for review. And what we're asking for there is the permission to go ahead and bid those, come out for bid when we get those. Try to expedite that.
Any action from us?
Just authorization to advertise for bid once the plans are approved.
I like that motion.
You could just say so moved. It's the same thing.
So moved.
We don't even have to second that, do we?
No, it's automatic. All in favor?
Second.
You should have said so moved.
Carries. The Lowe's pump station, grease problem.
Yeah, we have a lot of accumulation of fats and grease in that station. And you might need to kick in on this, but the floats that control the operations of that station will get hung up on the top of that grease and just float on up. And then the guys have to go out and reset that, vacuum the grease off the top. What we're asking for here is a submersible digester, which basically chops all that up, keeps it in suspension, allows the pumps to clear it on out, and also that improves your biologic process on the way to the plant. You don't input so much septic material to the plant. I miss anything?
No, the only thing is too, like if you get a bunch of rags in there and stuff, instead of a whole bunch of rags trying to come in to pump at one time, where this keeps everything circulated, it'll pass like one rag, and then maybe later on pass another rag, so you're gonna have less clogs.
Do you think it's the accumulation of rags and grease, or the accumulation of grease
A little
that's
bit both.
causing the issue?
What about, like I said, you start forming that mat on top, and then floats have to hang, and then as the level comes up, the float turns up. Well, if it's already laying on that mat, it can't turn up anymore, because that mat's just coming up.
Is there a chance that, once we pass it from here, that it could get clogged up somewhere else then, or? Is there
Shouldn't
any
look
other
the new pumps are
stations?
putting in.
Is there any other pump stations down the line we need to look at if we do this?
The only one goes to the depot, and
So if we do this, we need to monitor depot a little bit more to see if it starts screwed up and then put one in too.
I mean, you're still gonna get rags.
Right.
When you vacuumed it off, what would you do with
Yeah.
it?
They dump it over at the dry bed stove plant.
Okay, so stuff that we previously put in one place, we're gonna pass through the system, but it'll be in such a state that it's not going to cause trouble somewhere else,
You're not
right?
gonna get the grease buildup, because you're constantly
Mhm.
sitting there keeping all this broke out.
You have a combination of this digester and then the chopper pumps have already approved.
We've always had an issue with this pump station.
And we got chopper pumps at the depot right now.
Those are just big grinders or.
Mixture right now.
Well, we need to maybe look at that today. It's something to hit later then.
Big as that pump is, I mean, you all just, what stuff falling in there is usually the only thing getting in trouble with it, the rocks or brick or something like that.
Those big pumps will pass large
Bigger
material.
solids.
I'll make a motion that we accept the quote from KLM Sales and Service for the improvements to the Lowe's pump station, now $11,500.
All in favor? Opposed? Motion carries. Advertisement for audit services.
That time again.
This time again, we gotta do that.
So I just did that too.
Yeah. Okay.
Make a motion that we authorize to bid for the annual audit services.
All in favor?
So Wilson Company can give us a bid.
I thought last year we
Opposed.
decided we were gonna do more than 1 year at a
We
time.
couldn't. Legally, we can't do it.
Carries.
We wanted to do that and we found out we couldn't do it, so we have to do it every
We talked about it.
Emergency water supply agreement.
Yeah, we have interconnects with several of the water companies around us. Did get a contact from Syersville. They would like to enter into an emergency agreement where we can supply them water when they have shortages. I would like permission to go ahead and have David draft an agreement within our limits of what we can actually provide without hurting our customers.
Was the dollar amount changed over years? You know, last time you looked at it, it was about a 2 to 3 year old deal, isn't it?
The rate,
The rate?
yeah, that's per city ordinance. So
year. But is that additional than what we charge currently for out-of-town rates? Or is that just?
That's a flat rate. We could look at maybe getting that changed. But currently, that's by city ordinance, what that rate would be.
And that's a what, 3 years?
It's been several years since that was set. It's more than 3.
We need to look into that, because compared to what we're charging our current out-of-town people, that needs to be looked at.
Well, what we need to look at is wholesale rates, other companies.
Between now and the next meeting, why don't we come up with a rate structure that we think is more equitable given where we are now?
Then give it to the city.
Give that to the city and at the same time go ahead and start drafting the agreement.
That's good.
Thought being that they will go ahead and approve that.
Any other action needed?
I don't have anything else under other new business right now.
Okay. So we just agreed that David's going to start drafting the agreement. Okay.
Can you go to executive session?
Yes.
Make a motion that we go into executive session for
Potential litigation and personnel.
Second?
those two.
All in favor?
almost didn't say it. I thought you were second.
Motion to return to regular session.
Make a motion to turn to regular session.
Second.
All in favor? Report.
Report, the commission did take action with regards to 3 items regarding personnel that will be withheld pending notification to the employees, and they did address 2 matters. While not taking action on, did address 2 matters regarding potential litigation, otherwise no action was taken.
There was another matter that we didn't,
Back up, yeah.
and that was concerning the recommendation for the Bell Engineering's recommendation with regard to the
It was item 8A under new business.
Below me.
influent and effluent. So, is there a motion to accept and proceed with Bell Engineering's recommendation?
And we have to say what that is. We were gonna do their first recommendation dealing with the influence on the recommendation for existing influent weir flow metering of 18-inch magnetic meter, estimated currently at $139,150. And on the effluent, we assume that we are going to look into doing the option of portable construction cost for replacement of the existing effluent metering of $72,250, stated in the report given by Bell Engineering.
Plus engineering costs.
Plus the engineering cost.
That's your motion.
That's my motion.
Second.
All in favor? The motion carries. Is there a motion to adjourn?
So moved.
Yes. Right here.